In case if you love logarithmic function, guys, it's a sad news. Today is the last day we are dealing with it. It's heartbreaking. Okay, let's get it started. And also today we have a good news that Sean is gonna give us a tune.
Sean is not here yet.
Not yet. He should join, I assume. And Ninja and Samantha, thank you very much for submitting your, I should say, homeworks. And please, Samantha, please submit your homeworks on the Schoology.
Oh, okay. I thought you just
It's
take a
guaranteed it's
picture.
done. I have to show that to the inspector that the students worked and they do not accept anything from my mailbox.
Oh, I'm so sorry about
No
that.
worries. If I show that from my mailbox, they fire me.
Oh,
In case you want me to get fired, please do so.
Okay, yeah.
Good morning, Sean.
Good morning.
I like the energy of the morning
I'm so
which you have.
tired. Huh?
I like the energy which you have in the morning.
May I play the song on Monday?
Oh, actually, we were talking about that. We said that we are surprised, we are excited. You are going to give us a tune today.
I only practice a part of the music, so.
No, you want to do that on Monday?
Okay. So
Yeah, sure.
I deeply encourage that Samantha will sing the song today. It was a big surprise.
Yes,
No
Samantha,
way. Not even think about that.
And not only you can sing the Chinese song, but also you can also sing the English song. It depends on you.
Oh, right? Yes, Samantha, you can do that?
Yes.
No.
Yeah, English song is better.
And I'm sure Ninja can also join you guys, and also he can sing and join you all guys, you three all. Yes, Mingjae?
No.
I'm dragging Mingjae also into this.
Music club.
Guys, you three can form a band and find a name for your band.
Yeah,
Sean, Samantha, Mingjae, they become a band. They all sing together.
Yes.
Oh my God, that's a terrible idea.
How about you, Mingjae? Do you like the idea?
No.
Sean, it's on you then. You play the instrument. You have to convince them to join your band then.
Yeah.
I leave that to you, Sean.
Okay. I'll practice the music.
That's so true.
Give me 2 days.
Oh, Sean, we were waiting for your music today. But Sean, I have a very sad news for you. Sean. I have a very sad news for you.
What is the sad news?
The sad news is that today is the last day that we are working with the logarithmic function.
Really?
That's right. And Mingjae and Samantha already, they are so sad because they love the logarithmic function and they can't say goodbye to it. Yes, Samantha and Mingjae?
We can't say goodbye to it.
For the moment. Good morning, Linda.
Good morning, teacher.
How are you?
Fine.
Awesome, thanks. Guys, you can also have Linda in your group for singing a song. Linda, do you like to sing a song?
No.
No? Okay. Sean, then you are giving us a tune on Monday?
On Monday.
You're giving us a tune on Monday?
2 songs I prepare, I think.
2 songs. And
one Chinese song and one English song.
Oh, really?
Yes.
Do they have a name?
It has the name, but I don't want to as a secret.
Oh, you want to keep that secret? You want to surprise us with that, huh?
Yeah.
Okay. Okay, no worries, man. No worries. We want to be, honestly, on Monday, we just want to be surprised because we're coming back from the break. People are they have stayed home, and that's a good thing to do that on Monday compared to Friday.
Yep.
I think I love the idea of having that on Monday than Friday.
That's so true.
That's right. Even better. Thanks for changing the plan because I think now Monday is best because Monday people come to the class after Saturday, Sunday, staying at home, and Monday they're gonna have 2 songs.
I think today is the best day to wait for Samantha's singing. Samantha's song.
Samantha, would you like to do that?
Would you like to do that?
No way. Not even
No.
think about that.
Oh, really? Oh, you made us sad.
Freestyle.
Sean,
Freestyle.
you already arranged. I already expecting you like playing the music.
I appreciate it, but I really do not.
It's okay. It's
I
kind of a
prepared
part of
yesterday
it.
for 4 hours, not 4 hours last night, but it's not very proficient.
It's okay.
And
okay.
I just wake up at 9. I just wake up at 9. I do not even have a breakfast.
Sean, you woke up at 9?
Yeah, I wake up at 9.
Are you right now in the bed and watching the lectures?
No, I'm not in the bed. No.
No, imagine you wake up at the 9. Oh man, this is ideal. You open your eyes to the word and you start your day with the advanced function.
Yeah, I
That's
wake up at
superb.
9 and I open the course at 9 too.
That's superb, superb. Open your eyes, start the day with the advanced function.
That's right.
Yeah. Guys, I know that you can't wait for the new lesson today. Then I can't keep you waiting here. Now we are going to move on with the new lesson, which is exponential functions.
Teacher,
Yes.
Oliver today no come class because
Sorry, what? Hello?
he no come to discuss.
Sorry, I don't know what's wrong with the...
Wait.
Sorry, who's speaking, guys? Sorry. Is it Lisa? Is it you?
Yes, he can has class today.
You have a class today?
10th.
By 10 you have a class, huh?
No,
谁
because
你说他是谁？你说那名字？
he internet is down.
Oh, today your internet is down.
Yes, he home.
Okay.
Okay.
Anytime, Linda, anytime you got the disconnection or anything happens to the internet, we are gonna, the lectures is recorded right now. At the end of the day, I'm gonna send you
No, it's Oliver.
About the Oliver, huh?
Yes.
Let him know it's okay. I'm gonna just give him the present, but on the attendance, but he can watch the lectures online. I mean a recorded format tonight. I'm gonna send the link.
Okay.
Fantastic. Thanks, Linda, for letting me know about that. Thank you. And say to Oliver, that's no problem at all, and it's totally fine.
Okay.
Thank you. Guys, today the plan is this. We just start with the exponential functions and and equations, I have to say, because we talked about the function before. Talk about the equation very briefly, then we talk about the logarithmic inequalities. Then at the end, we solve the Sean's problem, which he had once. Sorry, Sean, it took a while to get to your question.
No problem.
Okay. But anyhow, guys, by the way, I have posted the homework for you, and it's a lot. It's too much question to deal with it, and the deadline is that for Wednesday. And you start working on it for the whole weekend then.
Wait. What I miss? What?
I said that I have posted the homework for you on the main website on the Schoology.
Oh, okay.
It's about all logarithmic function. It's too many questions. Too many. Please start working on it as soon as you can because you may miss the time.
Millions of questions.
Around so many questions. Then it's too much. Then please start working on it as soon as you are done with this class because you may do not have enough time. You have to submit it by Wednesday midnight. Then hurry up, please. Because we are going to have, after that, we are going to have a quiz and the midterm. Then it's a good reason to get practice. Guys, now, the thing is that now we are going to talk about, yesterday, we ended up session with the logarithmic, I should say, equations. We saw that in the logarithmic equations, we essentially followed a very simple strategy. We said that at the end of the day, either we had two main strategies. I'm going to review off the thing which happened yesterday. We said that if we have a logarithmic equation, everyone see what I'm writing, guys? Yes? Nice. We said that if we have a logarithmic equation, we have two main strategies. The first one was that we said that we follow this rule. We said that if the log of x with the base b equals to the log of y with the same base, that's right, then we can assume that, no, we do not assume that, we show that x should equal to y, correct? We did that, this exercise, the last exercise which we did yesterday was this. We said that if you have two logs on both sides of the equality sign, and you check that the bases are the same, then you conclude that the main drivers should be the same. And in case if the bases are not the same, what do? You make them to look like the same. You know property number 7, correct?
Yes.
And the other thing, it was method number 1. For method number 2, you saw that it involves more steps. Method number 2 involved that you isolate on one side all the terms which they have the log functions, then use property number 5 and 6 to make them to look just only one log function, which involves the functions of the x, and the base is gonna be b, which all equal to a constant number, for example, c. Then in order to solve that, you converted that into, let's say, an exponential representation to solve this. And you said that, okay, it's gonna be b. Everyone see this if I write here?
Yeah.
You see that the result is gonna be b to the power c should equal to f of x. That's right. And that was 2 methods of solving a logarithmic equations, which we dealt with that yesterday, correct? Do you need more exercise on this, guys, or you're fine?
Fine. It's okay.
Everyone is fine?
Yes.
Okay, let me. I think you should. Linda, are you fine? Linda.
Yes, I am fine.
Awesome. Mingje.
I am fine.
Awesome. Super. And now that everyone is fine, we are just gonna move on to, although I cannot, okay. I move on to the second topic, which was going to talk about, it is going to be about the exponential equations, because yesterday we talked about the logarithmic equations. Now we move on to talk about now exponential equations. As you may guess, the form of the exponential equation should be like that. We talked about that a little before. We said that for exponential equation, we assume that the bases are going to be the same. We say that, for example, I have one base here, which it has a function of f of x, should equal to another base. That base also has the same equal, the bases are the same. Then guys, when you look at this equation, what can you conclude? The bases are the same. Then what has to be the same? Then you can say that f of x also should equal to g of x. Does it make sense to you guys? You say that, okay, because I have the same basis, huh? Then I should conclude the head should be the same. That's right. Okay. And now I'm just going to give you two examples. When I have two examples for you, you get a good, I should say, understanding of the concepts of, I should say, exponential equations. The first example is this. The first one, I'm going to give that to you. We also covered that a couple of sessions ago. As a first example, I say that I have a base is 2, and the exponential is 2x minus 9. Should equal to what? 64. Everyone sees this? Yeah?
Yes.
Awesome. Guys, now I want to solve this exponential equation. But first of all, why do I classify this as an exponential equation? Can anybody tell me why that classification is valid at this stage? Can anybody tell me? Because somebody wanted to say something?
Oh, wait, okay.
Are you stretching, Samantha?
I'm just using the scientific calculator.
No, don't solve it. The main question is that so far we know 3 different type of equations. The quadratic equations, we learned yesterday about the logarithmic equations,
Yeah.
and this one is exponential equation. Why? Because I see the variable, the unknown variable in the exponents part of the function, correct? That is why I classify this equation as an exponential format of the equations. Okay, in order to solve this, I go back to the main idea of exponential equation. What is the main idea of exponential equation? The main idea is this, that I always make sure that the basis of the function is the same. Be the same. The theory is this. I call this the theory, the main theory of exponential equation, that I make sure, guys, that the basis on both sides where I have the unknown variable x as an exponent matches each other, be the same. Yes, Mingjae?
Yes.
Yes, that's nice. Then as a result, if that's going to be the strategy, if I say that, if you give me an exponential function and ask me to solve it, then I close my eyes and I say, okay, you were so nice that you give me an exponential equation. If I want to solve it, I have to close my eyes, make sure that the bases should be transformed in a way that they be exactly the same of each other. I move to this equation, guys, which I have. On the left side, what do I have? 4. What is the exponent?
Wait.
Can you see that, guys? Do you see the exponent?
Yes.
What is that?
I'm calculating it.
Do you have some problem to read
3.
that? Maybe that's the light, because of the light,
It's,
huh?
is 2x minus 9 equals 46, equals to 3. Right?
Oh, that's right. That's right. You just went a little step ahead, but that's correct. I say that for that case, I make sure that the bases should be matched. What do I mean? I mean that based on that theory, I see that one of them is 4, but the base on the other side is 64. How to make them look like each other? I know that 64 can be written as what? If I look at the base 4 to the other side, I see that if I take the 4 to the power of 3, it becomes 64. Clear, huh?
Mm-hmm.
Yes, Linda?
Yes.
Yes. Then I'm going to rewrite this equation. If I rewrite this equation, I write 4 to the power of the 2x minus 9 should equal to what? The right side. Instead of writing 64, I'm going to write 4 to the power 3. Correct? Because 4 to the power 3, now it has two benefits for me. The first one, which is the obvious one, is that it's again 64. The original equation was 64. The other main important benefit is that it is matching now with the base that it carries the unknown variable. Yes, everyone?
Mm-hmm.
Yes, nice. And now I close my eyes and think of this theory which I learned. I say if the bases are the same, essentially the exponents also should match. Then as a result, I simply close my eyes and I say, then 2x minus 9 should equal to 3. The exponents from the left also should equal to the exponents from the right because the bases are the same. And is it clear how to solve this equation now? 2x minus 9 equals to 3.
Mm-hmm.
How to solve it, Linda?
Fine.
How to solve this equation? Two x minus 9 equals to 3. Are you thinking of taking 9 to the other side?
So
Yes.
it becomes 2x equals 12.
That's
X equals
right.
to 6.
That's right. Thanks, Samantha. Then, Linda, what is going to be the next step? I isolated the term which it had x to the left. I took 9 to the right, and I changed its minus to the plus, then becomes 9 plus 3 becomes 12. Now I have 2x equal to 12. How much is the x, Linda?
6.
Linda? Huh? Linda?
6. Teacher, no, hear me.
Huh?
X
You
6.
cannot see that?
I can see.
Sorry, I can't hear you.
What has happened?
Linda, are you fine?
Yes.
Do you see what I have written here?
Yes.
2x equals to 12. What do you guess x is going to be?
6.
Fantastic. Fantastic. Thanks, Linda. You finished. You put the final touch to this equation. Then, guys, as Linda said, the equation is satisfied if I put x equal to 6. If I put x equal to 6, I get 2 times 6 becomes how much? 12 minus 9 becomes 3. And you see from both sides, the exponents matches. Then if you want to check that, if you want to check the thing which you did is fine because you can say, okay, I move from here, put it back to see if the equation matches again. And now we solved the first type of the exponential equations by looking at this theory that the base should be the same. If the base is the same, the exponent should be the same. Any questions, guys?
No.
No.
No? Mingjae?
No problem.
And Linda?
No problem.
Awesome. Samantha?
No problem.
Is there anybody else in the chat, in the room?
Nope.
No? Okay. Now, we move on. Let's put the dates. Today is April
3rd.
3rd, 2020. Page 1. Okay. Now, I'm going to give you one example. Then you please think of it. Then I solve that for you. Ready, everyone? I'm sure you cannot wait. All of you are excited to solve this equation.
Hey, I have a hard time to see. Now the light is so close to the paper, I think.
Is it good now?
Yeah, better. Yep. Thank you.
Awesome. Everyone can see that? Yes?
Yes.
Yes.
Linda, Sean?
Yeah.
Okay. And guys, look at that. I give you one question, and that question is this. I say, please solve this exponential equation. The equation is this 2 to the power of the x, which all of them is giving the power of x plus 3. Please solve this one first, then give 2 minutes on it. You do not need to solve it now. Just familiarize yourself with this. I'm going to solve it myself in 2 minutes. Just see what idea you have in order to deal with this one. But we can solve it together in case if you think that this is a little bit challenging one. Okay, guys, do you get any idea how to tackle with this?
So I know the exponent, it should be negative 2. So what I'm thinking is multiply, like adding x and x plus 3 together.
X. You say adding x and x plus 3 together, huh?
Yeah, equals to negative 2.
You have an idea? That's great. Awesome. How about the others? Mingjae, Linda, Sean. Mingjae?
My result is negative 2.
To be honest with you, I haven't solved it yet. I don't know what is the result. But I'm looking for the idea. Let me just start to see what happens. Guys, the first thing before we move on, and I have to raise that with you, is this. That I'm gonna put that inside these 2 parallel lines as a note. I call it here a note. And my note to you is this. If you have a, which is going to be the base. Your base goes to power n, correct?
Mm-hmm.
And all of them goes inside another power, which is m. Like I'm building the note matches the question which I have. I have a base. The light is good, guys. You have no problem seeing the paper?
No problem.
Awesome. Everyone, Mingje, Linda, Sean, you are good?
Yeah.
Awesome. Then you see that. Linda, are you fine?
Yeah.
Awesome. Then guys, you see that when I have a base with the power n and all of them goes inside the pocket, that pocket takes everything with the exponents n, the result is going to be this. You write the base a and you write n times m. You multiply the powers together. You do not add them. You do not say n plus m. You say n times m. Yes?
Mm-hmm.
If that's going to be correct, then what are we going to do? You're going to come in here, say, okay, if that is going to be the case, then from the equation which I had, I have 2 and 2 to the power of the x, and x plus 3 should be multiplied to this, correct?
Mm-hmm.
It multiplies. Then I have 2 to the power x times x plus 3. And to the right side, and there my problem begins to start. I know from the theory which I learned, I have to always, in exponential equations, the equations which they have the unknown variables into the exponents parts, I have to always struggle to make the bases to look like each other. Correct? How can, if the base of the left side, which carries the unknown, if I say, okay, I'm not going to mess around with this base. I'm afraid of this base, guys. I don't want to mess around with it because it carries the exponent which has the unknown variable x. I don't want to mess around with it. It's too powerful. I don't want to struggle with it. I don't want to wrestle with it. I keep it there. I don't want to look at you. You are so dangerous. I try to manipulate the base on the right side, which is 1 over 4, in order to make it look like 2. Guys, how can I make 1 over 4 to look like 2? Huh? Hello?
Hello, I was just like, I'm picking up something up, so just hold on a second. I need to mute a moment. I'm listening. I'm sorry.
Okay, sure, no problem. Mingje,
Yeah.
how can I do that? How can I make 1 over 4 to be equal to 2?
I made 2 equal to 1 over 4.
You mean 2 equal to?
I didn't change the 1 over 2. I changed 1 over 4. I changed it to 2.
You change to the base of
Yeah, I
1.
changed the left side.
Okay, we can, but normally we do not deal with this because you have to take minus to all these ones. That's correct, but this time I just wanted to deal with this. Then I'm going to say 1 over 4. I'm going to make a note here, guys. I say 1 over 4, I can write it as 2, but the power of the 2, I put that to what? To minus 2. Why? Because, guys, you remember that I take another side notes. I call it as note number 2. As another side notes, I say that 2. I just don't write 2. I say that if A goes to the power minus n equals to what? 1 over A to the power n. Do you remember it, guys? Yes?
Yes.
I use this note number 2 to change 1 over 4 with 2 to the power minus 2. Then you see that, then it becomes 2, then it becomes 1 based on this note 1 over 2 to the power 2 becomes 1 over 4. Correct?
Yeah.
Nice. Yes, Linda?
Yes.
You are okay? You remember these concepts?
Yes.
Awesome. Samantha, Sean?
Yep.
Nice. Then the thing which happens later is that at that last stage, I see that, okay, at this stage, I see the exponents can match because the bases are the same. Then as a final step, what I'm going to do, I'm going to say that I'm going to expand this to this. I say x times x plus 3 should equal to what? Minus 2. Correct? When this one is going to be very easy because it's going to be a quadratic function and you are now the master of solving these equations. You know that? You can just simply expand this and instead solve this equation. x2 plus 3x, that's right. I'm taking minus 2 to the other side, becomes plus 2 equals to 0. Correct? That one is fine now?
Yeah.
No question?
No question.
No question. And you solve this equation and you see how much is going to be the x. How much did you get for the x, the Mingjing?
I got -2.
And Mingjing, just one very interesting question. Because you see that at the end, we end up with the quadratic function. Quadratic function implies that we should have two results, two solutions.
Oh, yeah.
Then you got -2, then you have to have another solution. What is the other one?
I need to calculate.
No worries, you can do that later, but your approach is correct. But sometimes it's good. That's why I said that normally stay away from manipulating the base which carries the exponents of unknown.
Hey, I'm back.
Oh, welcome back.
Yeah.
Then it's good to always manipulate the exponent that they are free.
Yeah.
Yes, Mingjay?
Yeah.
Yeah, but your approach is right. Maybe somewhere just something went wrong. That's why I always avoid to work with the base which carries the unknown as an exponent. I normally work with the other side. But essentially, when you solve this equation, I'm going to write this at the back at the end. This one you can just write as x plus 2 times x plus 1 equal to 0. Then you see your basis becomes -2 and -1. Then x should be either x equals to -2 and x equals to -1. Then we have two answers when we just solve this equation. Interesting, huh?
Yeah.
Any question, guys?
Yes.
Everyone is fine?
Okay, let me catch up. Just give me a second in this page. Oh, so I was wrong. It's what the hell?
You open the video.
I know.
Super.
No, it's just this accident. Okay, so I was wrong. It shouldn't be adding up. It's multiplied by 2 exponents.
That's right. Then, guys, I just want to review that once more. Hi, Arya. Then I just want to catch up very quickly.
Hi, teacher.
Good morning.
Morning.
Morning. If you just, Arya, if you missed the first part of the lecture, it was very important about the exponential function Please watch the video when I post it on YouTube today. I'm gonna send the link to you by tonight then. I send the link to everyone on the announcement part of the course. Please make sure that watch the first 40 minutes.
Okay.
Okay, thank you. Guys, then as a result, you see that if the theory is that to make the bases look like each other, when you deal with the exponential function, I always recommend you to mess around with the base which carries not the exponent as it has the unknown variable. Always manipulate the base which is free. Then if you do that, you get out with this equation, and you see that you reduce your exponential equation to a quadratic equation, which you expect to have two results for it, which one of them is going to be -2, the other one is going to be -1. Correct? I just, if you have some problems still with it, we're going to do one more example about the exponential function, then we move on. But also, if you still have any problems with it, ask me now, or you can watch the video. Do you have any questions, guys?
No.
Who said no?
Me.
Samantha?
Yes.
Awesome. How about you, Minje?
No problem.
How about you, Linda?
No question.
Are you fine, Linda? You can reproduce the same thing?
Yes.
Awesome. How about you, Sean?
Not at all.
Awesome. And how about you, Arya? You joined, I think, recently. You can catch up with the question with the next one, huh?
Okay.
Yeah? Awesome. Then, guys, I think the time is my battery of this my laptop is almost dying. It's now 9:45, huh?
Yep.
Let's take a break for 15 minutes. Then when we come back by sharp 10, then we run the session from 10 to 11, huh? Then from 10 to 11, we continue with more exciting stuff, more interesting stuff. Then please, guys, enjoy your break. I see you back in 15 minutes by sharp, not by sharp 10. Okay, guys? Awesome. Enjoy your break. See you in 15 minutes. Hello, guys.
Hello.
Everybody back? Samantha is back. Anybody who is back, please say your name so loud.
For sure.
Minxi.
Lisa.
Oh, nice. All of it, everybody in back then. Okay. Let's move on. You were sharp back by 10. I'm impressed by myself, I should say, honestly. Okay, now. Okay. Let me see what topic is left. Okay. Let's guys move on to another example. But before we move on to the next example, so far, as I just want to, hi David, are you back?
Yeah.
Awesome. David, please, I'm going to send tonight the first half of the class that you missed. I'm going to send the link today to Schoology. It takes you to the YouTube of the recorded video for today. Please watch the first 45 minutes.
Okay.
Okay, thank you. Guys, then before we just go for the break, we dealt with the most simplest cases that you will see exponential function. You see the bases are the same, then you inferred that f of x and g of x should be equal because they have the equal base. Now we are going to deal with the cases that it is not always possible like that. There is to just make the bases similar, but you may always go for a general case. The general case that we're going to deal with it is going to be, for example, I'm giving you one example. Then we use a logarithmic function because if you remember, before I just write the example, we said that previously, if we have a base, which it goes to the power of the x, gives you f of x, then you saw that you can write the logarithm like that. You say that you can write it like this, that you say that also it's equivalent to the log with respect to the base b of f of x should equal to x. Correct, guys? Then you notice that previously there are two ways. We said that the exponential representation and the logarithmic representation are essentially two sides of the coin. They are interchangeable. From this representation, you can jump to this representation. From this representation, you can jump to the other representation. I'm going to use this property now. That, for example, let me turn off my cell phone. It's being picked too much. For example, I have this equation. I have, as an example, I have this equation. I have 2. The power is x plus 3 should equal to 7 to the base x, to the power x. Guys, please focus on this very beautiful example of an exponential functions, which it makes you desperate to solve it, I should say. Look at this one. A very beautiful exponential equation. If I'm going to explain this to you, how to deal with this, then we move on. I give you one more chance to do some examples on your own. Guys, look at this one. For this equation, the problem is that if I just want to adopt the previous method which I had, the previous method told me that, where is that? It's the previous method that I used, it was telling me that if you have an exponential function, make sure that the bases are equal. You see both sides bases are b. Then you can infer that the exponents should be equal at the same time, as long as the base are kept equal. Then you say f of x equal to g of x. On all the examples which we had, we solved two examples. The examples were designed in a way that you were able to manipulate the bases from both sides to make them equal, correct? But in this exponential equation, the problem is a little bit more intense because I cannot make bases 2 and 7 to match. There is no way I can just write one base with respect to the other base as an exponential format, correct?
Correct.
Do you see that?
Mhm.
I do not have, for example, 2 on this side, I have 4 to the other side, then say 4 is going to be 2 to the power 2, then the basis becomes the same. Make sense?
Makes sense.
Now, what can I do right now? The strategy is becoming different now. The strategy is this. I go back to the main definition. I say, then I have an exponential format of an equation, which it makes me desperate. I have no clue to find the answer. I'm going to represent it by the other representation, which is a log representation.
Okay.
Then it's going to be very easy. I say, okay, I want to change the representation. The representation which I have right now is exponential format. I mean by exponential format, I'm representing this function. Now I want to change the representation. From the exponential representation, go to the logarithmic representation. Is it clear, guys?
Yes.
I'm now transforming the way which I represent the function. I'm going to represent it now to the logarithmic function. How can I do that? It's very simple. As you learned previously, in order to change your representation to the log representation, you say, okay, I'm going to take the log function from both sides. Right? Then I'm going to take the log from both sides, but I'm going to behave it like more scientific way. Either you can take that, you have two different logs, which is easy to work with them. Either you can take the log with base 10, which is very easy to work with that inside, I should say in computational, stuff. Or the other choice which we have is gonna be the log with the base e, which we learned yesterday about that. And we noticed that the e is, how much is e, guys? 2.71. Everyone remembers that?
Yes.
Everyone remembers that the e was 2.71 from yesterday's lecture. If you can't remember it, please go to the video to review the contents from the yesterday. And we learned yesterday, we can show log with base e as ln. It was essentially half of the class yesterday to talk about the natural logarithm. It was a natural logarithm yesterday that we talked about that. We said that the log with the base natural e, it's written as ln. I have two choices to make in order to transform my representation from exponential representation to logarithmic representation. I have two weapons, either use log base 10 or ln function. I prefer normally to just work with the ln because this is more scientific. Then I'm going to take this weapon, apply it to both sides of the main equation. That's right. Then what I'm going to do, I'm going to take ln from both sides. Then I'm going to write ln of 2. What is the power? X plus 3 equals to ln of 7 to the power x. Correct?
Yes.
Everyone sees that?
Yeah.
Then at this stage, my representation is not anymore exponential representation. My representation is a logarithmic representation. Yes?
Yes.
Awesome. Give me 1 second, please. Okay, now when I'm at the logarithmic representation, guys, I have always 7 properties that I have to remember them for the rest of my life. One of those properties was what? That when the main driver of a logarithmic function has a power. You remember that? Then we said that you can imagine that someone is driving a Lamborghini and wearing a hat and the hat falls off. Yes? Now, it becomes very easy now. Then from this representation, I'm going to write it in the format which I use property number 3. Do you remember that? It was property number 3. Then I'm going to write x plus 3 ln of what?
2.
Of 2. Correct. Equals to what? The same
X.
story for the x.
Yeah.
Because
X.
huh?
Oh, sorry. It's okay.
Yeah, please go on.
XL and 7.
Fantastic. That's right. Because I see the hat, it falls behind the function as if x plus 3 fell behind the function. Yes? Then it becomes x ln 7. Correct, guys? Makes sense to everyone?
Yes. I'll just keep saying yes, but I just found out I mute myself.
No, that's great because I like people to participate because it says it keeps me moving. If you stay silent there, it's bad. I do not feel motivated to continue that. If you say yes, no, it's very good because otherwise I think that I'm talking to myself then. Yeah, please do so. Please do so.
I almost yelling to my laptop. I was like, why nobody hears me? I was like, oh, I mute myself.
No. I hear you and everybody hears you and that's good. Please everyone say yes, no, because that's way I understand you're up to the pace which I move. Huh? Yeah. Okay. And now I got to this stage right now, guys. And now you see that ln2 and ln7. What are these creatures there? I have ln2, ln7. What are they, guys? Are they function or they are just a pure number?
Pure number.
So true, because ln2 and ln7, it is like number 3, number 4. You can put this into your calculator.
That's so true.
Number 3.7, for example. Then that's something you can just deal with it as a number, not a function. Then right now, ln2 becomes like the pure coefficient that I can expand it to this expression. Then what can I do? I can say ln, at the next line, I can say ln 2. It is a number right now.
Yeah.
I'm going to take it, act it into 1x once on 3. That's right. Then I have ln2 now is acting as a pure number into the x plus ln2 times 3. ln2 times 3 becomes, for example, 6. That's a known value. Equals to what?
ln 7x.
That's fantastic. ln 7 times x. Correct?
Yes.
Fantastic. Then now I'm at this stage. ln 2 times 3, it's a noun number. It's like 7, 10, 12, anything. But x is something which is unknown then. Then now, guys, you are dealing right now with one basic, simple algebraic equation that you know that you have to isolate x on one side and take all known quantities to the other side. That's correct?
Yes.
Everyone sees this if I put it here?
Yes.
Yeah, okay. Now, everyone sees this one, huh?
Yeah.
Okay, now what to do? I'm continuing from this. Now, the terms, guys, that they are unknown either is ln2x and ln7x. I'm going to isolate the terms which they carry the unknown quantity to the left. I mean, then I just start to write it by ln2x. I write x in green. It tells you that this is something you have to find this out. I'm taking ln7x to the left side. It becomes what?
Minus ln7x.
That's so right. Minus ln7x. And I'm taking the unknown, which is known, ln23 to the other side. Becomes what?
Minus ln23.
Fantastic, because ln2 times 3, it's a known quantity. Pull up, I should say, your calculator. Find what is ln2. Multiplied by 3, you get the number. For example, 1.2. Yes? Now we ended up to this page. It becomes page number 2. It was done 2. Becomes page number 3. Page number 4. It becomes page number 5. Okay. And now, I'm at this stage now. You see now I have two terms which carry the unknown quantity x. But the best thing is that I factor x and write it like that. I say I'm going to have two terms. I factor x. What is left inside then? If I factor x from these two terms.
So it's ln2 minus ln7.
That's so right. I factor x, then becomes ln2 minus ln7x equals to what? Minus ln2 times 3. Correct?
Yes.
Awesome. Guys, now we are moving back, I should say, to the secondary school. And the question is that, how much is the x? That's maybe for 3 years ago that you learned how to find x. To divide both sides of the equality by the coefficient of the x. Then it means that I have x. The right side becomes minus ln2. What? 3. What is here?
Is ln5. Negative 5. Sorry. Okay.
No.
Oh, sorry. ln2 minus ln7. Sorry.
That's right.
I
Guys,
can't minus like that.
remember, please, guys, remember, you do not, under any circumstances, you say ln2 minus ln7 becomes ln, let's say, for example, ln5. You do not add the one in front of the ln, because Samantha, if you remember, we said that the log function, as if you just go to a restaurant, you go to a Red Lobster restaurant, you order a lobster, they bring the lobster with the crust on top of the lobster. You do not eat it like that. You have to, break the crust on top, then they eat the white meat inside. Then the ln and the log functions, they are like that crust on the red lobsters. You have to break them before you do any algebraic manipulation. That's right. However, you can, if you want, you do not have to, you can say, okay, ln2 minus ln7 equals to ln2 over 7. Property number 6. Huh?
Yes.
But this is no need to do that here. That's we end up at this stage.
Mm-hmm.
Huh?
Yes.
We end up at this stage. And you see, guys, how beautifully we solved this equation.
Yep.
Fantastic. Thanks for sharing your enthusiasm. and I have this one there.
Next question.
Right. Guys, any questions now?
No.
No, everyone's fine?
Yep.
Yeah. Awesome. Linda, how about you? Linda,
Yes.
are you fine?
Yes.
Do you have any questions on this one?
No question.
Are you sure?
Yes.
Great. Then the question was this, and they ended up with the answer. How about the Aria? Any questions? Aria? Aria? Mingzhe?
No questions.
No questions. Sean?
Not really.
Okay. And who is left in here? David? Samantha?
No problem.
No questions? Nobody? Okay.
No one. Perfect sense.
Awesome. Awesome. Okay, guys. Now, I'm just going to give you an exercise. It's going to be a little bit, I should say, maybe more challenging, but let's do this exercise. Then let's solve this equation. I'm trying to find a cool exercise. Okay, I'm going to give you this exercise. It's going to be a very easy one before I give you something which is going to be more work for it in order to consolidate the things which you learn. Guys, please, you just solve this equation. I'm going to give you this equation, and that equation is going to be this. The equation is going to be 3. The power is going to be x plus 1. It's a very simple one, but it's a good thing that you can practice it now. 5 to the power of the x. Mingzhe, is it okay?
Yeah.
Yeah, awesome. Guys, who's done now? Anybody?
Not yet. Just hold
Okay, sure. Please take your time.
on. Okay, so is it
Are you done, Samantha?
I do have an idea, but I didn't like really calculating it. I know how to do it.
Yeah, please share your idea with us.
Yeah. So basically, is like you change it into log. Is L log E 3x plus 1 equals log E 5x.
You mean ln, huh?
I mean log E, and then you change to ln. I don't want to show the step. Is that okay? Yeah, and it's just all equal to ln 3x plus 1 equals to ln 5x, and then you move the exponent in front of this function. So is x plus 1 ln 3 equals x ln 5.
Fantastic.
Yes.
That's the right strategy. That's great.
Yes, and then you just like putting x plus 1 and multiply by ln 3. It's gonna be ln 3 multiplied by x plus ln 3 equals to ln 5 multiplied by x.
Oh, that's fantastic. That's the right, I should say. That's the very right approach. Great job. Thanks.
Yeah, and then you just move the ln 3 to the right side of the equation and move ln 5x into the left side.
That's fantastic. That's the very right strategy. Thanks. Thanks, Samantha. Great job.
Problem.
Awesome. Ningxie, you're done?
Yeah, I'm done.
Awesome. What is the end result?
X equal to negative ln3 over ln3 minus ln5.
Fantastic. Fantastic. Great job, man. Thank you. Sean, what is the result?
1 point something.
1 point. But Sean, remember, Monday, 2 songs.
No. Okay. Deal.
Deal. Awesome. Guys, Monday, when you come back to the class after the long weekend staying at home, we are going to be really, I should say, entertained. Sean is playing 2 musics then. Fantastic. Linda, how about you? Are you done?
No.
Not yet? No worries. I'm going to solve it now. Arya, how about you? And David?
Not yet.
Not. Was it David?
No, David.
Yeah, I'm here.
Oh, are you done?
No.
Not yet. No worries. I'm going to solve it now. Then you can follow with me. But guys, please, I want to ask you, please, you see that if, now I'm going to say that later. Guys, look at this. In order to solve it, you see that there is no way to make the bases to be equal. 3 and 5, they are different. Then the thing is that I take the ln from both sides. Then I take the ln from both sides. And then what happens is that if I take the ln from both sides, it becomes ln of 3 the power x plus 1 should equal to ln 5 to the power of the x. Then you see that you can just remove these hats as an exponents, fold them behind the ln, then you write the function like this. You say that x plus 1 times ln 3 equals to x. Yes, Linda, so far so good. ln 5. Then you expand ln 3 because this is a known quantity into these two terms. Then you end up with what? You end up with x ln 3 plus ln 3, because ln 3 times 1 becomes ln 3, equals to x ln 5. Correct? To the right side. Then the next step is that I want to isolate the x terms on the left side, which it means that I can write x ln 3 minus x ln 5. I take this one from the right, Linda, to the left, then becomes what? I take ln 3, which is a known quantity, to the right, becomes minus ln 3. The next thing which I can do is that I can factor x from these two terms to write what? To write ln 3 minus ln 5 times x equals to minus ln 3. ln 3 is a known quantity. You put that into your calculator, you get the number, and it seems that's the noun variable. But that's the x which we do not know. And we are essentially now, by here, we are back to almost 2 years ago when we did the basic math. We know that in order to get the x, we divide both sides by the coefficients of the x. ln 3 minus ln 5. I divided both sides by the coefficients of the x on the left, which is ln 3 minus ln 5. And I have minus ln 3 on top, ln 3 minus ln 5. There we are done. Guys, everyone got the same answer?
Yep.
Excuse me. And you see that ln 3 is a noun quantity, ln 5 is a noun quantity. You put that in your calculator, you see how much it gets. But this stage, if you have it on the test, quiz, anything, midterm, stage is fine. Do not continue further. Any questions, guys?
Nope.
Nope. How about you, Samantha?
No.
How about you, Linda?
No.
How about you, David?
No.
How about you, Arya? Ming?
No.
Awesome.
No, teacher.
Awesome, great. Ming-Jae?
No questions.
No question. You got the same thing, huh?
Yeah.
Awesome. Fantastic job by you all. Guys, thank you very much for your hard work. You are doing a great job on the math, and I see you all.
What about my previous question?
We are getting there.
Oh,
We are giving a couple of minutes.
okay, no problem.
You have one more exercise to do.
Okay.
Because Sean, that's the lesson itself. I have to teach the others first because now we are working with the equations.
Logarithm.
And the next step is going to be the inequalities.
That's so true, inequality.
That's the lesson of itself. That's a tough lesson. Then I have to make sure that the people are at that stage.
Okay.
Then, my friend, don't rush. We get there eventually.
No problem.
Awesome. Thanks, Sean. because Sean, it's a lesson of itself, inequalities.
Okay.
Then,
oh, really?
yeah, that's
So,
right. That's
About
right.
next week we will learn this.
Either this one today or Monday, definitely we get to the inequalities, because I was planning to finish everything today, but we are behind of the time. Then
Okay.
Monday we finish the logarithms. Then
Fine.
the people who love logarithmic function, guys, be very happy. Probably Monday it should be the last day on that topic then. Okay, let's solve the very last example of the logarithmic equation. This is a very important exercise, guys, because you have to do a change of variable. That's maybe the first time you do that in the math. Then please listen to that very carefully. The thing which I have for you is this. I want to ask you, please solve this equation. I ask you, please solve this. The log of x all to the power 2 minus 2 log of the x minus 15 equals to 0. Let me highlight it by a different color. This is a new technique. You are going to learn it through this exercise, which is very important. This is, everyone sees this, huh?
Yeah.
Yeah? Guys, please take 1 minute only to find if you can think of any strategy which you can use to solve this equation. Oh, Sean, this is almost 10:40. I thought if we can reach to that question then, but I'm gonna promise you, Sean, Monday we have the lesson completely about the logarithmic inequality. That's right. And we solve your equation 110% on Monday.
No problem.
Because I have to make sure that the people get enough good understanding of what is an inequality in the logarithmic function then. Because Sean, when the base is less than 1, there is a twist in the logarithmic inequalities, then people have to know why that twist comes from. Then that's a lesson of itself.
Okay.
Yeah, thanks, man, for understanding.
No problem.
Thank you. Guys, are you done? I do not expect you to solve it, but do you know what needs to be done? Hello?
Hello?
You fall asleep, guys?
No.
No? What's the plan now? Inge, Samantha, Sean, Linda, Arya, David, Brian, Stefan, Philip, Gonzalez. Wow, what these names are. Who are they?
Gonzalez.
You just say Gozela then.
I'm creating the names that they do not ever existed in my class. Gonzalez.
Gonzalez.
Alex. You know what? Like yesterday I was in CIA and Osama.
Sorry, what? Yesterday what?
Yesterday CIA, you know, is a class name. Say
CIA?
Yeah.
American Central.
CIU. Wait.
CIA?
Is the
It's an organization. It's an institution in America.
That's right.
It is CIA. CIA for you is the
Central Intelligence Agency.
That's so true.
You studied that? Are you serious?
No, it's a class name. It's a,
Oh,
it's a
the
business
same name as the
Yeah.
Central Intelligence Agency.
And you know,
Samantha is a member of Central Intelligence Agency. Oh, are you going to?
okay, shut up. Okay, so basically the teacher that's
That's
called,
great. That's great. Wow,
like
Yeah.
that's unbelievable.
Stephanie for a
What
couple
are you? What are you going to draw to our class? To do you have some?
Oh, now you're just being a jerk.
No, what happened, Samantha? You went to CIA or you have a class, this is called CIA.
Yes, CIA.
This is the name of the course?
Yeah, CIA.
What is that course?
Business, economics.
Ah, there is a new guy teaching that. I think his name is,
Osama.
yeah.
Yeah, Osama just keep calling me Stephanie. And
Oh.
Stephanie.
yeah, there's no Stephanie in either of the class. Your whole school, there's no Stephanie. He just
Okay, then in order to just catch up with Osama, I'm just gonna call you Gonzalez.
Gonzalez.
Oh, that. Me
from
too. Me too.
From now on, I gotta call you Mr. Gozella.
But guys, honestly, I don't know how did I get that name on my phone, Gonzalez. But now that I pronounce it, I feel that's quite a beautiful name. You say Gonzalez. Oh, I love it.
That's a cool name, actually.
Yeah.
Guys, let's we do not have much time. Let's deal with this one. Then we can finish the lesson today. On Monday, when we got back, we deal with the inequalities of the logarithmic functions. Okay, guys, when you look at this, oh my God, I'm thirsty. Give me 1 second to drink some water.
So for this question, I think we can move the real number to the right first. So you just separate them. And then,
hey, Samantha, you're talking how to do this one?
Yeah.
What's your idea?
I think, so basically you just like put the 15 on the right side of the equation. And then you using the way like you put like exponent in front of this functions. So is 2 log x minus 2 log x equals to 15.
Oh no, Samantha, when that's a very good point that you mentioned. That's a very good point you mentioned. I just want to state that. That's a very good point. Guys, look at that. There is an alarm coming here. Look at that. We said that the log, everyone is with me now?
Yes.
Say your name, guys, everyone. Say your name.
Samantha.
Mincy.
Gonzalez.
Oh my God, I love that name. I love
Gozella.
Okay, guys, look at that. And now everyone is here. Listen to that very carefully. We said that the log x, if n is the hat for the x, can be written as log x and n falls behind. We have no question on that. That's so far so good, huh?
Yep.
But if you have log x and the whole, I should say, expression goes to power n.
Equals
to
log nx.
Log x times log x and goes on n times. Then log x to the power n, everything to the power n is not equal to n log x. Yes, Samantha?
Yes.
Guys, I made the same mistake when I was at the high school. Look at this one. Make sure that you do not do the same mistake which I did before. If the n is the power for the main driver, you can bring it back. But if the n is the power for the whole function, you cannot fall it off. You see?
Yeah.
Everyone says yes if you got it.
Yes.
Awesome.
Yes.
Awesome. Awesome. Linda, Arya, David, no yes from you?
Yes, yes.
Oh,
Yes.
great.
Yes.
I'm glad everyone got it. Then as a result, the strategy is going to be different. The strategy is then you cannot take 2 to the other side. What else you guys think? What is the best strategy? Give me a hint. Minji, Sean, Linda, Arya, David. Give me a clue. Minji, any idea?
No.
Sean, any idea?
Just like Samantha said.
You said what?
Just like Samantha said.
Ah, Samantha.
Oh, Sean, you are dirt.
No, he's a gentleman. He's a
Yes.
gentleman. We'll let you go first.
No. Okay, whatever. So, okay,
Guys, listen. You're getting to the end of the class. Let me solve this.
let
This
me
is the
think.
very first time that you are going to use this technique in the advanced function course.
Yeah.
I'm going to do something. I call that the change of variable. You see, this function is to the power 2, and something comes with power 1 and a constant. It reminds me of our popular quadratic function. What was our popular quadratic function? Was this x squared plus x plus 1, for example, equal to 1. It is our popular function as a quadratic function, right? Then I see, for example, 15, if I put it there. It's so similar to this. You see that? If the log of the x is x, you see that it has power 2, it has power 1, and something as a coefficient. You see that similarity?
Yes.
Yes? Then, guys, I look at this similarity and I say, oh my God, this equation reminds me of someone which I know. I want to have a makeup on it and represent it like this function which I know. I'm going to say, what time is it now?
It's
12 minutes.
10:48.
Awesome. I'm going to say, guys, if I think of, where is my marker? If I, guys, look at the log x as, let's say, I call that z. Huh? You can call this anything. You can call this even Gonzalez, guys. It doesn't matter. You call it z, anything. You call log of x, z, Gonzalez, u, a, anything. The thing is that you're changing its name. And you're going to put this one, this step, guys, you haven't done that before in the whole math so far. They call that the change of the variables. I say if I change the log of x, the main unknown, to z, I'm going to rewrite the main function. What happens if I rewrite the main function? I'm going to come from here to here. What happens if I rewrite the main function again? Instead of log of x, I put what? Z. Huh?
Z. So it's z squared minus 2z minus 15 equals 0.
That's so true. You see these guys here right now?
Yes.
That now if I change the variable to log of x to z, I have the popular what? Popular quadratic function, correct?
Okay, so it's gonna be, you just take z out of from this equation. So is z, sorry.
No, Samantha, the easiest way, you made it very complicated. The easiest way, how to solve z in this quadratic equation?
Oh, okay, wait, I know. It's just like you using the okay, it's z minus 5 multiplied by z plus 3. You're just factoring it. And
oh, you factor this, huh?
yes.
You say that if you want to solve this equation, Samantha said, let's factor this and writing it to what, z?
z minus 5
Okay.
multiplied by z plus 3 equals 0.
Fantastic. Fantastic. Because in that way, you see that if you expand these two terms, you get the same thing. You
Yeah.
get z2, z squared. The sum becomes minus 2z, and the product becomes minus 5 times 3 becomes minus 15. Fantastic. Then you see that, guys. By doing so, you get two things. Once you get z equals to what? Plus 5.
5 and negative 4 or negative 3.
That's so true. The other z becomes what? Negative 3. Because you say once this term z minus 5 equals to 0, then you get to this point z equal to 5. Once also z plus 3 equals to 0, which it can happen only and only if z equals to minus 3. Correct? Guys, we are doing a phenomenal job so far. And you are making my weekend a great one because you are doing an exceptional job, guys. Thanks for the hard work. Okay, I'm gonna have this. Now I have two roots. One of them is gonna be 5. The other one is gonna be how much?
-3.
Guys, what's the problem now? The page number. What's the page number? 6. It's gonna be page number 7, and it's gonna be page number 8. Guys, anyone sees this page?
Yes.
Any questions so far?
No.
Any question? Samantha?
No.
Mingzhe?
No.
Linda?
No.
David? Sean?
Oh,
No.
Aria? Okay. If there is no question, then the problem is that, guys, we were able to find solution for the z. We know for sure z is going to be either 5 or z is going to be minus 3. But we have to go one step back because I was looking for the log x, not for z, because in the main equation, my unknown quantity is a log of x. I had to change it to the z. Huh?
Yes.
Is it clear?
Yeah.
Then now I have to again go back to find the roots which I have for the log x. Guys, it's going to be page number 9. Guys, I just made this change of variables that the log of the x is going to be z, correct?
Correct.
And I got z to be how much? Either it has to be plus 5 or
negative 3.
z has to be negative 3. I'm gonna just follow with this one first. I said that, first of all, I assume that z is gonna be plus 5. If, guys, z is plus 5, you can expect what? You can expect if z is plus 5, log of x is plus 5, correct?
Yes.
Because it's very easy to see that. Because you said z is equal to 5, because I saw this quadratic equation which resulted from the change of variable, then you see that if x equal to plus 5, z is equal to plus 5, it means that because log of x is equal to z, because of the change of variable, it means log of x is equal to 5. That's right?
Yeah.
Then the question, how much is the x now? I know that the log is base 10 because I didn't write it in 10, huh? Guys, how much is the x?
So
use the calculator.
No.
no, it have a square.
That's right.
A b square. Blah, blah,
I
blah.
have the log representation. I've moved to the exponent representation. by keeping the b to the power of the x equals to f of x. Then this one means what? This one means if I want to change the representation, different color, it means that I keep the base 10, correct? I start from the backseat driver, go to the backseat, which is 5, equals to x, correct? Then I got the first answer. The first x is gonna be 10 to the power of 5. So far, so good. Any questions?
No.
No. And now, also, guys, I had another z. Another z was how much?
-3.
That's right. I had z equals to -3.
Yeah.
Means what?
Means
I put it back up there to the log function.
log
X equal, yes, Samantha?
log x equals to -3.
That's right, log x equals to -3 because log of x was equal to z.
Yeah.
How much is the base?
It's 10.
I want to change it to the exponential representation. What do I get? I go to the back seat, which is 10.
10 -3
to the power -3. Then I move to
equals to x.
x. And I was looking for the x. Wasn't it correct?
Is yeah. Okay, so question.
Yeah, sure.
Why the base number is 10?
Oh, okay. Because that's a very good question. Let me find my notes. Because the base is 10, because if you go back to the main equation, I said log x, and I didn't mention the base. When I do not mention the base, in all the science, it is assumed that if you do not write the base, you are making the assumption that the base is 10.
Oh, okay.
Guys, in the test, in future, in the next 100 years, if you go anywhere, you see that the log doesn't have any base, it means that the base is 10.
Okay.
That's right. Then essentially, it was also here, the base was 10. Oh my God, that was a beautiful equation. Wasn't that?
Yes, it is.
Yeah, awesome. Guys, any questions?
No.
Samantha?
No, I'm perfectly clear.
Gigi?
No.
Linda?
No.
David? Sean?
No.
Arya? Okay, guys, we have less than 1 minute. I have to remind you of the things. Please check the website, check the assignment homework. The deadline for it is Wednesday, midnight. There are too many questions. Starts working on it. And at the same time, you're going to have the recorded video of the today's lesson before the night, before 8 p.m. In case if you have any needs for any clarification, send me your questions, email me your questions, and watch the video during your spare time. Okay?
Okay.
Awesome. Guys, if there is no question, I wish you a very nice weekend and see you all by Monday.
Yes.
Thanks, everyone, and have a nice day.
Have a nice weekend.
Thank you, Samantha, and
Goodbye.
you too.
See you.
Thanks, Sean.
Thanks.
Bye.
Thanks,
Teacher.
Mingjae. Bye.
Bye.
Thanks, Linda. Goodbye. Brian, David.
Bye.
Bye. Thanks, Mingjae. Have a nice day, Mingjae.
You too.
Bye.
Thank you. Thanks, David. Have a nice day. And Arya, have a nice day.